Question 1. Which of the following best describes a key difference in scaling considerations between AI model training and AI model inference? Option A. Training primarily requires low latency, while inference prioritizes high computational throughput. Option B. Training often demands long-running, high-compute jobs, whereas inference typically requires low latency, high throughput, and elastic scaling. Option C. Training typically uses general-purpose CPUs, while inference exclusively relies on specialized GPUs/TPUs. Option D. Training benefits most from serverless architectures, while inference is best suited for dedicated on-premises hardware. The correct answer is: training often demands long-running, high-compute jobs, whereas inference typically requires low latency, high throughput, and elastic scaling. Here's the explanation. The exam tips highlight this distinction. Know the difference between scaling for training and scaling for inference. Training often demands long-running, high-compute jobs, while inference requires low latency, high throughput, and elastic scaling. Question 2. When an AI model is too large to fit into the memory of a single GPU or accelerator, which distributed training technique is most appropriate to split the model itself across multiple devices? Option A. Data parallelism. Option B. Horizontal sharding. Option C. Model parallelism. Option D. Batch processing. The correct answer is model parallelism. Here's the explanation. The How It Works section explains. Model parallelism. For extremely large models that don't fit into a single accelerator's memory, the model itself is split across multiple devices, with each device computing a portion of the model's layers. Question 3. A company needs to deploy an AI model for a new mobile application feature, where prediction requests are intermittent and unpredictable, but rapid scaling to zero when idle is crucial for cost efficiency. Which inference scaling strategy is generally most suitable, despite potential cold start latencies? Option A. Deploying on a dedicated Kubernetes cluster with fixed node count. Option B. Utilizing serverless inference via functions, e.g., AWS Lambda, Azure Functions. Option C. Vertically scaling a single large virtual machine with multiple GPUs. Option D. Implementing edge inference on user devices. The correct answer is utilizing serverless inference via functions, e.g., AWS Lambda, Azure Functions. Here's the explanation. The How It Works section and exam tips describe serverless inference as scaling to zero when not in use and rapidly scaling up on demand, offering cost efficiency for intermittent or unpredictable loads, though with potential cold start latencies. Question 4. An engineer needs to troubleshoot a sudden spike in application errors and wants to review detailed, time-stamped records of events generated by the application code. Which type of data collected by cloud monitoring services would be most appropriate for this task? Option A. Metrics. Option B. Logs. Option C. Traces. Option D. Events. The correct answer is logs. Here's the explanation. Logs are described as detailed, time-stamped records of events generated by applications, operating systems, and cloud services. Logs provide granular context for troubleshooting and auditing, e.g., access logs, error messages, system events. Metrics are numerical data points. Traces show end-to-end request paths, and events are notifications about state changes, none of which provide the granular detail of application errors like logs. Question 5. Which scenario would most likely necessitate the installation of a software agent for data collection in a cloud monitoring service? Option A. Monitoring the storage usage of an Amazon S3 bucket. Option B. Tracking the number of invocations for an Azure Functions app. Option C. Collecting detailed CPU utilization and application logs from a custom application running on an EC2 instance. Option D. Observing the read/write latency of a Google Cloud SQL managed database. The correct answer is collecting detailed CPU utilization and application logs from a custom application running on an EC2 instance. Here's the explanation. The study material states that for customer-managed resources, like EC2 instances, self-hosted containers, agents are often installed on the operating system or application to collect detailed CPU, memory, disk I/O metrics, and application logs. Options A, B, and D refer to managed cloud services, where metrics and logs are automatically emitted via API-based collection, requiring no agent installation. Question 6. What is the primary benefit of establishing a baseline of normal operation in cloud monitoring? Option A. To reduce the cost of monitoring services by limiting data collection. Option B. To define the expected or normal behavior of a system against which current production data can be compared to detect anomalies. Option C. To automatically remediate issues without human intervention. Option D. To improve the security posture by encrypting all collected monitoring data. The correct answer is, quote, to define the expected or normal behavior of a system against which current production data can be compared to detect anomalies. Here's the explanation. The exam tips section highlights that baselines are crucial. They define the normal state against which production data is compared. This allows for effective alerting and anomaly detection. The other options are not the primary benefit of baselines. Question 7. In cloud key management, what is the primary benefit of envelope encryption? Option A. It allows master keys to be directly used for encrypting large datasets. Option B. It ensures that the highly sensitive customer master key, CMK, never leaves the key management service, KMS. Option C. It replaces the need for data keys with a single master key for all encryption. Option D. It enables data encryption without requiring any cryptographic keys. The correct answer is, it ensures that the highly sensitive customer master key, CMK, never leaves the key management service, KMS. Here's the explanation. The How It Works section clearly states, this envelope encryption process ensures that the highly sensitive CMK never leaves the KMS, and only ephemeral data keys are used for bulk data encryption. Question 8. Which of the following network security components provides stateful virtual firewall functionality at the individual instance or network interface level within a cloud, virtual private cloud, VPC, or virtual network, VNet? Option A. Network Access Control List, NACL. Option B. Security Group / Network Security Group, NSG. Option C. Route Table. Option D. Web Application Firewall, WAF. The correct answer is Security Group / Network Security Group, NSG. Here's the explanation. The Key Features / Components section defines security groups / NSGs as stateful virtual firewalls that control inbound and outbound traffic for individual instances or network interfaces within a VPC / VNet. NACLs are stateless and subnet level. Question 9. An application running on a virtual machine in a private Azure virtual network needs to securely connect to an Azure Cosmos DB instance without its traffic traversing the public internet. Which Azure networking feature should be implemented to establish this private connectivity? Option A. Configure a public IP address for the Cosmos DB instance. Option B. Use a VPN gateway to connect the VM to Cosmos DB. Option C. Implement an Azure private endpoint for Cosmos DB within the virtual network. Option D. Utilize an Azure Service Endpoint for Cosmos DB. The correct answer is implement an Azure private endpoint for Cosmos DB within the virtual network. Here's the explanation. The use cases and exam tips sections explain that private endpoints create a private IP address for a service within your VNet, ensuring traffic stays entirely within the cloud provider's private network and does not traverse the public internet, offering stronger isolation than service endpoints. Thanks for watching. Please subscribe to my channel